So in the previous lecture we were seeing this problem. Transmission line is having the load impedance 100 plus j80 and the characteristic impedance of the line is 50 ohm, and our aim is to provide the impedance matching by connecting series stub, open circuited stub at a distance d from the transmission line, so that input impedance becomes equal to Z0. In the last class, we have derived obtained the value of distance d using Smith chart, and we saw that we are getting two solutions, that is d1 as 0.120 lambda and d2 as 0.463 lambda. Now in today's lecture, our aim is to find out what should be the length of this open circuited stub. This open circuited stub is connected in series, so we have to find out what will be the length ls. Now, so what is the technique behind the length ls? So the logic is, we will start from open circuited load. For this stub, this point is open circuited, this point. So we will start on Smith chart from the point which represents infinite impedance, because open circuit means infinite impedance. So we will start from here having infinite impedance, and we will keep traveling towards the source. Actually, we can call this direction as towards the source only. We will reach to that point where the reactance, we will travel that much length only, so that the reactance of this, that is excess, is equal to negative of reactance what it was at this point without the stub. So let us go back to Smith chart. We got two distances d1 and d2. This d1 distance, what we got, if we see this d1 distance, at this d1 distance at this d1 distance, my input impedance should be of this form. My input impedance should be of the form, it should be of this form, that is j of x, it should be a 1 plus jx, as we have seen, because not capital, we are actually working with the normalized quantity. So it will be small z1. We have taken z1, here we took z1. This z1 is this, we have already written z1 is 1 minus j 1.33. That means this is r is 1, and my small x is minus 1.33. So if the length of the stub that I connecting is such that its input impedance is plus j, that is impedance of the stub, say I am denoting by z as, it is like this, plus j 1.33. Okay, it is of the form plus j 1.33, it is of this form. Then if I add the total impedance z1 plus zs, then this part will cancel out and I will get only small r equal to 1. This is the logic. So you see the Smith chart now, it is minus, if you see the Smith chart, this Z1 corresponds to, if I draw the X, is like this. This one is minus J 1.33. Okay, this line is this small x value is minus J 1.33. So I have to travel from JD. So for this open circuit, I have to travel from infinity impedance point, and this point extreme right indicates the Z equal to infinite point. This indicates z equals to infinite. So I will start from here and travel that distance where my reactance is, as I told here, plus 1.33. That means from here I will travel in clockwise direction like this till my value is 1.33. Okay, suppose the 1.33 point will come here. Okay, so there I have to do, see here, if I consider, then this point is corresponding to 1.33. So I have to stop here. I have to stop here. That means the x point is, okay, I'm showing this part, it has become clumsy once again. See, this was my Smith chart. I'm just drawing a rough circle. That means what I got, this one as say 1.33. 1.33. This is 1.33 plus, this is x equal to. So what we are doing is we are traveling from this point, starting from here. This corresponds to infinity impedance. From here we will travel in the clockwise direction in such a way that I reach this 1.33 here. So now we can read this value from center to this 1.33. If I draw one line, and then we can read this value, and that will give the length. So if we read this value, it gives 0.147 lambda. Okay, it gives 0.147 lambda. So how much distance we have traveled, that will be the length. So again the same logic, from this it starts from 0 lambda, and one full rotation gives zero point 0.5 lambda. So from there, so how much we have traveled, what is the distance from here to here? This full is 0.25 lambda. First one full rotation is zero point 0.5 lambda. So now you see the rotation from here to here, this is half of zero point 0.5. So this will be 0.25 lambda. So in this 0.25 lambda you add 0.147 lambda, because this 0.147 lambda is coming from here. So it will be 0.25 plus 0.147 lambda, 0.147 lambda, this will come. So this is coming as 0.397, 0.397 lambda. So this is the length of the stub. Okay, in terms of wavelength, this should be the length of the stub. So this is one solution. Now I can have another solution, that is we got another impedance Z2 as 1 plus j 1.33. That means there my reactance is plus j 1.33. So I have to choose the length of the stub such that my input impedance is minus j 1.33. You understood? So it is just sign is changing. It is minus j 1.33. So again, I will start from this. So z, this from z equals to infinite, and I will travel that length so that my input impedance becomes minus j 1.33, so that after adding it cancels. Now you see minus, so again I can show clearly. Okay, so this is my Smith chart. So I will start from here because this represents infinite impedance. I will travel like this till that point where the reactance, suppose this is my reactance, this x is minus, it is minus j 1.33. So my, because negative is below, so minus j 1.33, so I will travel to this point only. So from center I will extend the line and I will note down the reading of the wavelength. Okay, this reading comes out to be 0.353 lambda. 0.353 lambda. 0.353 lambda it comes. So how much distance this is? This reading actually starts from 0 lambda. So this 0 lambda, so this is 0.25 lambda, this is 0.25 lambda, and this is 0.353 lambda. So my length of the stub, another solution comes out to be, it is just a subtraction of these two. 0.353 L2 will come as 0.353 minus 0.25. We have to subtract 0.353 minus 0.25. This is all lambda. So this comes out to be 0.103. 0.103 lambda. This is the second length of the star. Now lambda can be found out if you know frequency. Suppose it is told that frequency of 2 megahertz. So you do C by F, just do C by F, you will get the value of lambda, and that lambda value you have to put here, and then you will be able to. So that is how we find the length of the stub and distance from the load end, so that there is impedance matching. Thank you.